Hello and welcome. My name is Pam Ream. I'm the National Product Manager with Argent Canada. I'm very excited today to be able to bring you this presentation, and we're going to be talking a little bit about milling dentures and discussing a new strategy that is being released with Roland and Hyperdent on a two-step denture milling strategy. We're going to discuss the benefits of a milled denture, and then we're going to talk a little bit about strategies and what exactly is a milling strategy. And then once we've gone through all of that, we're going to go through this new exciting launch that they have coming soon. A little background on myself. I am a RDT and I've specialized in removables and dentures since 2012. I started out working in a full-service lab, working in the removables department, and eventually worked my way up to running that removables department for a short period of time. I was fortunate enough in 2019 to go work for a denturist, and as an in-house technician, together we were able to transition his clinic from fully analog to fully digital. Once we had mastered it at that clinic, I was so excited to share with others, and I started training other denturists and labs how they can transition from analog to digital. One of the pieces that I think is always overlooked is the actual milling strategy. How are we finishing these cases that we put so much work and effort into? We're adopting all these digital strategies, but how are we milling these cases? And how are we making sure that they are as accurate as how we've designed them? So today we're going to jump into a little bit about milling dentures, a little bit about strategies, and how we can adopt this new strategy that is just being launched with Roland. Before we get into the strategy, I want to talk about some of the benefits of a milled denture and why we're talking milled dentures today over printed dentures. Last year, I had the opportunity to attend the IDS trade show in Germany, and I was blown away at the size of it. And as you can imagine, everybody was talking about dentures. Every booth had a section about digital dentures. And as I went around, I had the opportunity to talk to denturists and lab owners from all over the world and see whether more people are printing or milling. And that really comes down to the economy that you're working in. If you're working in an economy that does have a insurance for patients, typically they are leaning towards a milled denture. So for example, in Canada, we do have insurance that covers dentures, and now we have a Canadian program that covers low-income dentures. Even most of those dentures are being milled, as they have to be able to last a bare minimum of 7 years, and most consumers are looking for at least 10 to 15 years. In the US, however, economy dentures are currently booming, and so a printed denture might be the best option if you're looking for a low-cost, maybe 2 to 3 year lifespan of a printed denture. So today I want to talk about the benefits of a milled denture and how it can potentially improve your practice and what you're offering. First is lower microbial adhesion. There was a study done that studied printed dentures, analog dentures, and milled dentures over the period of 6 months with a large amount of participants. And what they found was that the milled dentures had the absolute least amount of bacterial growth. They were studying Candida yeast at the moment, and it had the lowest amount of bacterial growth, with printed dentures coming in last. And the reason why is typically because a milled denture is milled out of a PMMA puck that has been processed at much higher densities than we can possibly process, even in analog dentures. As you can see by the study, analog dentures were right in the middle. So a milled denture, even though you are maybe using like an IVO-cap system or an IVO-based system and injecting your analog dentures, a milled denture still had lower microbial adhesion. And that probably has to do with the surface being milled as opposed to processed into a porous stone. There's no polishing done to the tissue surface after the milled denture has come out. There's no additional work that's done to that surface. And there's a much smaller amount of porosity in a PMMA disc compared to an analog denture. And so this ultimately had better outcomes for the patients. Less adjustments. Now this is just an internal poll that I had done privately, but I had reached out to a bunch of denturists across Canada and had them check their data in their system and see how many visits are they doing once they've gone digital. And it was no surprise to me, but it was unanimous across the board that they have gone down from 1 to 2 visits up from 3 to 4 visits. And so not only are you making a better product for your patients, you have a lot less adjustments because these are coming out extremely accurately. Because we are removing all the human error, starting from pouring models all the way to processing a denture, we can ensure that your denture is going to match that final impression almost exactly. I kind of mentioned before, but this is predictable material. It's the same material that we have been using for the past 100 years. It's just been formed into a puck. So if you want to do a reline, or if you want to do an adjustment, or if you want to do a repair, it's going to work exactly the same as your analog materials, because these materials haven't changed. They've just changed in shape. And it's not like we're moving into a new structure or a new molecular structure. Everything is exactly the same. And predictable workflows. So when we are doing an analog denture, there is always a percentage of cases that have a higher amount of porosity, a higher amount of residual monomer. Maybe there's stones stuck to the surface. Maybe a tooth has moved. The teeth will always move when you're producing in analog ways, but typically we can account for that and adjust these cases. A mill denture is never going to change structurally because we're not actually structurally changing the material. We're cutting it out of a material that's already been formed into its final version. So not only are you going to have more confidence in providing these to your patients, you're also going to have a much reduced amount of lab work. So before we go into this new strategy, I wanted to talk about what is a milling strategy. What exactly does that mean that somebody has developed a milling strategy? Now you can think of it kind of like a recipe. All of the different bits and pieces that go towards this strategy. And typically these strategies are based off of a certain set of burrs, and these burrs will have all of their diameters accounted for, and every little bit and piece of them, if they have extra coating, how big is the cutting surface, how many flutes does it have, etc., etc. And then they are programmed in a way to all work together. So I just wanted to go through a little bit of the language that you might hear when you're talking about strategies and what that might look like if you're on a trade show floor, if you're talking to your sales rep, if they're trying to discuss some of these things with you. What are these things and why are they important, and how do they fit into the overall picture of what a strategy is? So the first one is chatter. What is chatter? Chatter is just the vibration of the burr against PMMA, so it's not cutting it smoothly. What can cause chatter? If you have weak sprues or machine vibration, so if you don't have enough sprues holding your denture in, it can vibrate. Or if your mill is sitting on top of a plastic table, the whole mill could vibrate. And that's going to cause your burr to wiggle, and it's going to leave chatter marks. If you have a deep Z-step, the Z-step is the vertical up and down. So how deep is the burr penetrating into the disc on its first pass? And if it's pushing really deep into the disc, like all the way the depth of the burr, and now it's trying to grind the full depth of the burr, it's going to rattle that whole denture. It's going to cause some vibration. A worn collet or burr. The collet is that little piece that holds onto your burr. And if that collet is worn out or it was misused and it's not holding your burr correctly, your burr can actually slip in and out. And even if it's slipping at like extremely small measurements, it's still going to make a difference. If your burr is sitting too far out or too far in of the holder at the time of milling, it could cause chatter. The last one is feeds and speeds out of balance. So we're going to talk about feeds and speeds in a second, but here's an example of what chatter could look like. Now this is more from a machining perspective. This obviously is not on PMMA. This is on some kind of metal, but it's a good example showing how chatter marks could appear on your material. It would look the same on a PMMA denture as well. Speeds and feeds. So we did talk about this really quick, but what exactly does speeds and feeds mean? It's the movement speed versus rotation speed. So the feed rate is how fast the burr moves across the surface. And the spindle speed is how fast the burr spins in place. So a good analogy here is if you're mowing the lawn, if your blade spins really fast, but you walk at a steady pace, the grass is going to be cut smoothly. If you're running across your lawn or you're walking really, really fast, the mower is going to start to jump up and down on the little bumps. You're going to have uneven patches. That's chatter. Basically, your mower is bouncing along instead of smoothly going across the blades of grass. And if your mower is really running aggressively and your blades are spinning super fast and you're moving as slow as a turtle, you're probably going to burn the grass. In milling, this would be like melting PMMA or creating a really rough surface because you're moving too slowly. So really, you want the two of them to be balanced. You don't want the blade spinning too fast and you don't want the mower moving too fast or too slow. You want the two of them to be balanced in their movement. Very, very similar to your PMMA and how your burrs are cutting. Chip load. You might hear this one here and there. What is the chip load? And this is more important to make sure that you are using the burrs that are designed and developed for this strategy. If you're using the incorrect burrs, the chip load might be different based on that burr. So how much material each tooth removes, basically how much is it cutting each time. It's controlled by feeds and speeds, and it's also controlled by the number of flutes on the burr, like how many cutters are on the burr. So here's a couple examples that show how much material is being cut every time the burr spins. And so if you're using a burr that is slightly different than the one that this is designed for, you can see here that the chip load itself might be different because this flute, the flutes are the cutting surfaces here, might be a different length or width or size, or if there's a different coating on it, it might have a different thickness. That could affect the chip load. So if we have a good chip load, that means that we have good clean chips, good finishing, and a long burr life. We're not cutting our burrs out too short. If we have a bad chip load, so if it's not cutting enough material, it could have a lot of dust that could clog our machine. I know we have suction in these machines, but the suctions have been set to a certain amount of chip load and a certain amount of expectation of debris. And so if we have way too much debris, that could cause chatter. Or if it's cutting really large chunks out of our material, that could cause chatter because it would vibrate the material. So it's really, really important to use the burrs that are associated with this strategy because somebody has done the work to develop the correct chip load based on that specific burr. The last one on my short list is step over, which is basically how far the burr moves sideways between passes, so the distance between each tool path. So if there's a small step over, there's going to be a really smooth surface. The burr is going to overlap more with the previous path, but it does take longer to mill. If there's a large step over, the burr is going to move farther between passes, which could potentially leave scallops or ridges, but it's a lot faster. So if we're thinking about this like mowing our lawn, every time we mow one line and then we move over to the next one, are we covering half of the previous line, or are we going too far over and leaving some small blades of grass in between? This was just 4 very small examples, and it's just the tip of the iceberg to everything that goes into developing a strategy. There are hundreds and hundreds of more small, fine details that have gone into developing a milling strategy and all of the ways that the burrs interact with your material and interact with the mill. This takes a lot of time to develop, and like I said before, is developed specifically for a set of burrs that will be included with this strategy. So let's have a look at traditional milling. Typically what we're going to do is we're going to mill the teeth, mill the base, bond it, and finish it. Now, I have a really terrible example here. This is maybe a bit of an over-exaggeration, but this is what could happen when you are bonding your cases. You could have spillage, you could have overflow. Even if it's just a little bit, you're going to be questioning the teeth seating accuracy. You still have to remove all of the sprues that are on the teeth, and there's additional finishing required. And so you are adding one element of human error by bonding these and then just going straight to polishing and finishing them. So what if there was a better way? That's where the 2-step overmill denture process comes in. So step 1, you're going to mill the teeth. The teeth are going to be partially milled with the intaglio surface fully completed. So you can see on this photo that the intaglio surface has been milled to 100%. The occlusal surface, as you can see, has not been milled to 100%, and even the facial surface has not been milled to 100%. So you're going to take those teeth out of this puck, remove the sprues. You can leave them a little bit big, a little bit overhanging, and then you don't have to worry about that excess material coming out. So once we've milled the teeth, then we're going to mill the base. So just like the teeth, you can see in these photos that the intaglio surface is going to be finished and nothing else is going to be finished on this. This is so that we can get the roughing mill done as soon as possible. Here's another photo. And here's an example of the underside. You can see that it's milled to maybe 20%. The sprues are still left very large, and that is so that we don't have any chatter while we're moving the burr across. On this specific example, I may have added a couple more sprues to the lingual, but because they're left nice and thick after this point, you don't have to worry about that denture base moving or changing. Step number 3 is to bond the teeth to the base. So you're going to take the sprues off of the teeth, confirm that they drop into the sockets without force or tension, so make sure that it's passive, and then you can use the curing method of your choice. Some people like to use just a regular cold cure, some people like to use a tooth shaded light cure. There are a lot of different options, but you're going to cure this while the disc is in the holder. I don't like to take the base disc out of the holder. There is a workflow for that is included in this process, but it's easier if you leave it in the holder. Check for any voids or gaps or large blobs of additional cold cure, and then you're going to put it back into the mill for final milling. So once it goes back into the mill for final milling, that's when it's going to finish all of the around the teeth, the margins. It's going to finish the occlusal surface. It's going to cut those sprues down, so you can see that the sprues have been cut down so that you can easily remove this from the denture base. I have a little example of how easy it is to nest your cases in Hyperdent here. So you're going to select your size, and then you're going to name your disc to whatever disc you want to name it. So this is a 20 millimeter PMMA disc. You're going to pick the holder that's associated with it, and your file is going to appear into the puck. This is going to be very, very similar for the denture base. So you're going to select exactly where you'd like it to nest. You can turn it, you can angle it, you can change the position of it. And then all you have to do is add your sprues. Simply by clicking on where you would like them to be located. Again, it doesn't necessarily matter where they're going to be because we don't have to worry about smoothing them down after. That's why we're okay with putting them on the anterior, because the mill is going to smooth down those areas for us when we do the third milling step. Then you're going to select your strategy, and this is going to be the Elevate 2-step denture milling strategy. Calculate your tool path and send it to the mill. It's super easy, super straightforward, and not difficult at all to get these into the mill. It's very, very quick and efficient. So one thing that I always get asked about is, well, how long does it actually take to mill? Now, the numbers that I'm showing you are based off of some of the beta testing that we were doing, and they might alter a little bit with the final iteration of this new software. So keep that in mind, but currently what it looks like, so step 1, so this would be for the denture base. And when we're actually milling these, there is 2 options. So you'll have a speed option and an ultimate option. And the speed option is a little bit faster and it has a really nice surface finish, but the ultimate option really is what's giving you that shine and that gloss when it comes off the mill, and you're going to have a much cleaner finish coming off the mill. So if you would rather that this mill's a little bit faster and you have to polish it more, you have the choice to do that. There aren't any other strategies on the market with 2-step denture milling that offer options on how you want to use your strategy. It's one of the really nice features that I like about this new strategy. These are some examples that were sent to me by some beta testers, by Brock Vandor at Vandor Denture Clinic and Ryan at Prairie Denture Clinic. I'm really appreciative for any support that I can get when getting some photos of these. So you can see exactly how nice the milling finish quality is coming off of the mill. Here's a couple more examples of the tissue side. So there are some specks and flecks of PMMA dust on there, but these are straight out of the mill, and you can see exactly where the sprues are, that they've been cut nice and short. So the last thing that the strategy does is it goes in and cuts the sprues, but that lets these sprues stay nice and thick and wide for the duration of the milling process, and at the very end, it will cut the sprues off. One of these was milled with the speed option, and one of these was milled with the ultimate option. And realistically, you can't tell a huge significant difference. So if you are looking for the speed option, which I believe is this one here on the left, you might see a little bit of chatter, whereas the ultimate option is going to be a lot smoother finish. Here's one more example. So the one on the left was done with the speed option, and you can see there is a little bit of movement around here. That could also be because the burr is a little bit dull, but the ultimate option, as you can see on this side, comes out basically shiny and ready to go. The last thing I'll touch on is this very new strategy is also available for iVotion discs. So if this is something that you are interested in bringing into your lab or to your denture clinic, you can mill iVotion discs on the Roland 53 series with this new strategy. That's all I have for you today. This was a very, very quick overview. If you have any more questions, you can email that contact there. We're really excited to be able to roll this out and happy to help you guys moving forward. Thank you so much. Have a great day.